Welcome back. Today we are starting a new chapter, Polymers. As we look at our surroundings, we can see large varieties of things made of polymers. Plastic bags, cups, saucers, children's toys, packaging bag, automobile tires, electrical insulating materials, machine parts, etc. are polymers. The word polymer is taken from two Greek words, poly and mer. Poly means many and mer means unit or part. Polymers are referred to as macromolecules which are formed by joining large number of repeating units known as monomers. These monomers are repeating unit of some simple and reactive molecules and they are linked to each other by covalent bonds. The process of formation of polymers from repeating monomers is called polymerization. It is just like chain made of large number of beads joined with the help of thread. Here we have to compare beads with monomers and thread with covalent bond. The transformation of ethane to polythene is an example for polymerization. N number of ethylene molecule joining together to form polythene polymer. Here this is the repeating unit and on polymerization of the repeating unit you are getting polythene polymer. Another example is formation of nylon 6,6. Here N molecule of hexamethylene diamine polymerized with N molecule of adipic acid you are getting nylon 6,6. Next one, classification of polymers. Different ways of classification are there. First one, classification based on sources. First one, natural polymers. These are naturally occurring polymers and are found in plants and animals. Example, proteins, cellulose, starch, resins, rubber, etc. Second one, semi-synthetic polymers. They are chemically modified natural polymers and they are called semi-synthetic polymers. Cellulose acetate, that is rayon, and cellulose nitrate are examples of semi-synthetic polymers. Third one, synthetic polymers. As the name suggests, they are man-made polymers and are extensively used in daily life as well as in industry. Example, plastic as polythene, bakelite, PVC, etc. Synthetic fibers as nylon 6,6, polyester, etc. and synthetic rubbers as Buna S. Next category, classification based on structures of polymers. There are three different types based on structure of polymers. First one, linear polymer. These are long and straight chain polymer. PVC, that is polyvinyl chloride, high density polythene, etc. are examples. Next one, branch chain polymers. These are linear polymers with branches on their chains. Low density polythene is an example. Next one, cross-linked or network polymers. Cross-linked polymers or network polymers contain strong covalent bonds between various linear polymer chains. They are formed from bifunctional or trifunctional monomers. Bakelite, melamine are examples of cross-linked polymers. Next category, classification based on mode of polymerization. First one of this category is addition polymers. If monomer molecule possess double bond or triple bond, undergo repeated addition and form polymers. These polymers are called addition polymers. That is, they are formed by the repeated addition of monomer molecules. The formation of polythene from ethene and polypropene from propene are examples. Addition polymers are again classified into two, that is homopolymers and copolymers. The addition polymers formed by the polymerization of single monomeric species are known as homopolymers. Example, polythene. That is, n number of ethene molecules polymerizes to form polythene. It is a homopolymer because it is formed only from single monomer, that is ethene molecule. Polythene is an example for homopolymer and And what is the monomer of polythene? Polyethylene. So ethene is the monomer. Ethene means 2 carbon atoms are there with 1 double bond. So CH2 double bond CH2 is ethene molecule. Is it? If suppose that we are having 2 molecules of ethene, CH2 double bond CH2, then addition reaction taking place because it is having double bond. Okay, so in addition reaction, what will happen? This double bond get break, because double bond is easily breakable, and you are getting a compound like this way. I am writing this carbon atom CH2 now. I am writing the full length formula. So CH2, then carbon carbon bond C, again H. Okay, so what is here? Only 3 valencies. I have shown you only 3 valencies. No, 3 valencies of the carbon atom get satisfied with other 2 hydrogen atoms and with carbon atom. Is it? And we know that carbon have 4 valency, and we have to draw that bond valency here. Unsatisfied valency we have to show. And what about this one? This carbon atom, okay, make a bond with this carbon atom of the second ethane. So here carbon carbon single bond is there. Then we have to show the hydrogen atom here, no? 2 hydrogen atom. Then a single bond, carbon carbon single bond. Here also the bond break now. The double bond shifted to single bond only. That break, and here single bond only. Then we have to show that hydrogen atom here. So what about this carbon atom? 3 valencies satisfied with the 2 hydrogen atom and with this carbon atom. And 1 more valency is left with, that we have to show here. Okay, like that we have to do. Otherwise we can write it as, you see now, this one you can write it as CH2, single bond CH2, this carbon atom CH2, then CH2, like this way. Okay, here 2 molecules of 2 ethene molecules are there. Instead of writing CH2, these 2 ethene molecule, we can simply write 2C2, like this way, 2CH2 double bond CH2. Okay, and on adding with the adding these 2, you are getting this molecule now. Here consider that this is 1 unit, and the second one also the same, similar to the first one. That is, this is the repeating unit here. So 2 repeating units are there. Okay, 1, 2. So we can write it as CH2, single bond CH2, then like this way. Okay, how many? 1, 2. So like this way you can write. Okay, if suppose that you are having 3 molecules, okay, here you have to write 3. And if you are having n molecules, n number of molecules, then you have to write it as, here also n here. So in this case, polymerization taking place, addition reaction with n number of molecules, so polymer is formed. This is your polythene. Second addition polymer is copolymer. The polymer made by addition polymerization from 2 different monomers are termed as copolymers. Buna S, Buna N are examples of copolymers. Buna S is formed from 2 monomers, that is 1,3-butadiene and styrene. N molecules of butadiene and N molecules of styrene polymerizes to form butadiene styrene copolymer, otherwise called Buna S. Buna S is an example for a copolymer, and Buna S is formed by the copolymerization or addition polymerization of 1,3-butadiene and styrene. So we have to know how to write 1,3-butadiene. Butadiene. Okay, butane. So 4 carbon atoms are there. So I am writing this 4 carbon atom as 1, 2, 3 and 4. Okay, so here 1, 3 butadiene. So double bond is for first carbon atom and third carbon atom. So double bond, I am writing this double bond here. Okay, then we have to make here 2 bonds are there, so 2 more valency is there, so satisfied with the 2 hydrogen atom. Okay, and what about this carbon atom? 2 are there, 2 bonded with the 1 carbon carbon bond. Here carbon carbon single bond and double bond, so 3 bonds are there, so 1 is left, so we have to write hydrogen, 1 hydrogen here. Okay, and what about this third carbon atom? 1, 2, 3, so on fourth 1 with the hydrogen atom, and here 1, 2, so 2 with hydrogen atom to make 4 valency. Okay, this is 1, 3 butadiene. Okay, plus styrene. Styrene, we have to study that CH2 double bond CH C6H5. Vinyl group, no, PVC vinyl, that is CH2 double bond CH Cl. This is vinyl. Okay, like that, instead of writing chlorine, you have to write a benzene ring. So you are getting styrene. Okay, and if you are writing CH2 double bond CH2, Cl is vinyl, CH2 double bond CH2 Cn, acrylonitrile. This is acrylonitrile. Polyacrylonitrile is there now. This is the monomer for that. Okay, I'm simply saying only here CH2 double bond CH C6H5, that is styrene. Okay, on adding these two, here double bond is there, so simply the addition reaction will take place by breaking the double bond. You know, this bond breaks, this also break, this also. So you are getting here, you have to draw this valency as such, the fourth valency like this way, then CH, single bond CH, here also bond breaks, and CH2, it make bond with this carbon atom, so CH. I'm writing this C2 C6H5 here. Okay, so this single bond I'm writing, then CH, this one C6H5, this is C6H5, can you see that? Okay, C6H5. H5, then valency you have to write. Okay, suppose that n number of 1,3-butadiene and n number of styrenes are there, then this is the repeating unit. All the things are here, this as such is a repeating unit, so we have to write it n as such. Okay, so write everything together and put it as a single unit, then write n here. This is called butadiene styrene copolymer or BUNA-S. Second one of the classification based on mode of polymerization is condensation polymerization. They are formed by repeated condensation reaction between different bifunctional or trifunctional monomer units. Condensation reactions are reactions which proceed by the elimination of small molecules. In condensation polymerization reactions, the elimination of small molecules such as water, alcohol, HCl, etc. take place. Example, terylene, nylon 6,6, nylon 6, etc. For example, nylon 6,6 is formed by the condensation of hexamethylene with adipic acid. Nylon 6,6 is an example for condensation polymer, and they are obtained by the condensation of hexamethylene and adipic acid. So I'm going to write hexamethylene diamine. Hexamethylene, 6 methylene groups are there, so CH2 6. Okay, then hexamethylene diamine, amine NH2, diamine, so NH2. So 2 NH2 groups are there, that is hexamethylene diamine. Then adipic acid. Adipic acid is a carboxylic acid group, COOH. Let me write it properly. COOH. Then CH2 group 6 times. 4 times. Then COOH. This is adipic acid. Okay, you cannot see. Let me write it properly. CH2 4 times. Now it's clear, no? Okay. So condensation means elimination of a simple molecule. Here elimination of water molecule is taking place. NH2, instead of writing NH2 I am writing NHH. Here this OH group and H is eliminated out as water molecule. Okay, and you are getting NH2 CH2 6 times NH, this NH, then or otherwise I'll write NH. Okay, then here CO group, that means C double bond O, CH2 4 times COOH. This is the product obtained if you are having one molecule of hexamethylene diamine and one molecule of adipic acid. In the case of polymer, we have to take n molecules of both of these molecules, right? So what will be, you are getting, one more thing I have to tell you, that in hexamethylene diamine 6 carbon atoms are there. 6 carbon atom. Okay, and here 4 carbon atom in as methylene group and 2 carbon atoms from carboxylic acid group. Here also 6. Here also 6. That is why you are getting the product nylon 6,6. Clear, no? So n molecule of hexamethylene diamine and n molecule of adipic acid. So you are getting the product NH. Here you have to write like this way. Then CH2 6 NH, C double bond O, CH2 4 times C double bond O. This is the repeating unit and you have to put N over here. This is nylon 6,6. Or okay, you are getting nylon 6,6. 6 and 6 represent the number of carbon atom in the monomer unit. Okay, clear now? Next one, classification based on molecular forces. The mechanical properties like tensile strength, elasticity, toughness, etc. are governed by intermolecular force of attraction such as van der Waals forces and hydrogen bond present in the polymer. These forces bind the polymer chains. Here, the classification are done on the basis of magnitude of intermolecular force present in them. First one, elastomers. These are rubber-like substances with elastic properties. The polymer chains are held together by weakest intermolecular force in elastomers. These weak forces allow the polymers to be stretched. Few crosslinks are introduced in between the chains which help the polymers to get back to its original position after the force is released. Buna-S, Buna-N, neoprene, etc. are examples of elastomers. Fibers. Fibers are thread-forming solids which possess high tensile strength and high modulus. These are obtained by strong intermolecular forces like hydrogen bonding. These strong forces lead to the crystalline nature of fiber. Polyamides, that is nylon 66, and polyesters, that is terling, are examples. Next one, thermoplastic polymers. Plastic which easily get deformed on heating and can be bent easily are known as thermoplastics. These can be molded into different shapes again and again by repeated heating and cooling. These are the linear or slightly branched long chain polymers. These polymers possess intermolecular force of attraction intermediate between elastomers and fibers. Some common thermoplastics are polythene, polystyrene, polyvinyl, etc. Next one is thermosetting polymers. The polymers which once molded into a shape does not become soft on heating and cannot be molded again are called thermosetting plastic. They maintain their shape and size at high temperatures. These polymers are cross-linked or heavily branched molecules. These cannot be reused. Some common examples are bakelite, urea formaldehyde resins, etc. Next category is the classification based on growth polymerization. The addition and condensation polymers are nowadays also referred to as chain growth polymers and step growth polymers depending on the type of polymerization mechanism they undergo during their formation. These are the classifications of polymers. Thank you for watching.